Spearman correlation is another correlation that we covered in our class. And the Spearman correlation is denoted by R sub S, like that. And it's an alternative to the Pearson correlation that is used when, as I mentioned in an earlier video, when you have rank data instead of actual values, scale or ratio values, you have first and second, third place, just ranking. It loses all kinds of unit-based measurement, So when you have rank data, you use that, or the form of the relationship between the two variables is non-linear but monotonic. Okay. In other words, a monotonic relationship is a consistently one-directional or relationship that is not necessarily linear. That's monotonic. However, this is not monotonic because it's not one-directional. It's a positive, negative, positive, and negative. So it's not consistently positive or negative. And it happens, like a reaction time is something like that, is usually like this. So you can't use that. So you're gonna have to look at the scatter plot before you decide if you can use Pearson correlation or Spearman relation. You're gonna have to look at that first. Okay, so this is an example. For example, there are 5 students, and these are not the scores, but just the rankings. 1, 2, 3, 4, 5, 5, 3, 4, 2, 1. So why is it so different? It's really different because, look at that. Because they lost all, actual scores and measurements, so you can't really know the distance between the performance, the distance between this and this is just 1, this and this is just 1, this is 1, just 1. Which means, the actual score could be 100%, 80%, 75, 72, and 42, something like that. So difference is not actually equal, between these students of performances, scores. But when you turn it into a ranking, the distance is just 1, 1, 1, 1. Same equal distance. So that's the huge difference. That's going to affect the, hypothesis. And you can't use the Pearson correlation anymore because of that. So Spearman correlation, that's what you use in this case. But how? I was going to scatter plot, by the way. See, it's really... Anyway. Okay. Just apply the Pearson correlation to the rank data, and the Spearman correlation is minus 0.9. This number is based on, you use the same calculation as the Pearson correlation. So you apply Pearson correlation to this sampling data, and you get minus 0.9. And that's what the Spearman correlation is. Just to do a Pearson correlation on the ranking. And let's go Spearman correlation. So, for example, if you have data like this, remember these are scores, and when you see a scatter plot of this, it's really hard to say it's linear, but maybe it's like this, maybe it is one directional and it's non-linear but one direction monotonic. So if that's the case, you are allowed to do this. Turned into rankings. Okay. First, second, third, and fourth. First, second, third, and fourth, and do a Pearson correlation on that. Okay. But as you can see, because X rank and Y rank, they're exactly the same, so you get the perfect correlation in this case, and which is +1. Sometimes it's different, but in this case it's gonna be the same, and that's how you do. And you're gonna have to do hypothesis test on a Spearman correlation, but you have to use a special table for that. Okay, and you can't use the Pearson critical values for Spearman correlation. So what you're gonna have to do? What do you do then? Okay. The point biserial correlation can be used when one variable is an interval or ratio scale variable and the other variable has only two possible values. Oh, yeah. I can't find a table, but you get the critical value and you do the same way.